So there are two types of chemical reactions that we will talk about in this chapter, a non-redox and a redox. The non-redox is three types, either combination, double replacement, or decomposition. And the redox is a combination, single replacement, or decomposition as well. So let's start by defining the term redox. A redox reaction is a reaction where the elements in the reaction they lose and gain electrons. So when they lose electrons, we call this oxidation, and I represent it by the sound of the lion, like Leo says "gur." Okay, this is how you remember that loss of electrons is oxidation. So L stands for loss. So lose electrons, oxidation, and gain electrons. This is reduction in there. So oxidation number is also called an oxidation state. And these are the positive and the negative numbers assigned to the element in chemical formulas, of course, according to specific rules in there. And oxidation number is abbreviated by an OM. We did talk about oxidation numbers in the chapter before, and we said that this follows certain rules in there for metals. Metals always they lose electrons. Non-metals they do gain electrons, and when they lose electrons, I mean you represent this by a plus sign. A metal can lose one electron, two electrons, three electrons, four, etc. So group number one loses one electron, group number two loses two electrons, and then going to group number three, I'm skipping the transition metals. Group number three loses three electrons there. And then group number four can either lose four electrons or gain four electrons or have a zero charge. It really depends. And then group number five, it needs to gain three electrons in order to become octet. Group six, it needs to gain two electrons to become octet. Group seven, it needs to gain one electron to become octet. So this is why it's a negative. And the group eight is already octet, so it neither gains nor loses. So its oxidation number is always zero, zero. The rule says that there are multiple rules for oxidation number in there, and let's go over those one by one. So whenever we are working with an uncombined element, so what is an uncombined element? An uncombined element is an element that simply is either a solid, it's either a solid, like any solid, like magnesium solid, iron solid, calcium solid. So this is called an uncombined element. It's just an element by itself. Okay. So that has an oxidation state of zero. Zero. Same thing for the diatoms. So an uncombined element is the same thing as diatoms, because the diatoms, these are uncombined elements, meaning that it is not combined with anything else. So any diatom, like a chlorine, fluorine, oxygen, all of those, these are diatoms. Nitrogen in there, all of those, they do have an oxidation state of zero. So if you see any solid, one element solid, not two elements, one element solid in there, then the oxidation state is zero. And any diatomic gases, these are these have oxidation state of zero. Second rule, the oxidation number of a simple ion is equal to the charge on that ion in the periodic table. So magnesium, I mean, if you take a look at magnesium in there, magnesium, when it is solid, it's a zero charge. But when it loses two electrons, when it becomes an ion, it loses two electrons. So if it loses two electrons in there, then its a charge is going to be plus two. So I would say that the oxidation number for magnesium is a plus two. Same thing for the chlorine, the oxidation number is negative one, and oxygen, the oxidation number is negative two. So the oxidation number is equal to the charge on that ion. For oxidation numbers of a group 1A and 2A elements, when they are in compounds, these are always a plus one and a plus two, respectively. So if you look at sodium sulfide, for example, sodium is a group number one, right? So if it's a group number 1 in there, then it is going to be +1. And I know that sulfur is -2, then I would say, okay, the oxidation state of the sodium is going to be +1, and the oxidation state of the sulfur is going to be -2. Same thing for calcium. Calcium is group number 2, so its oxidation state is always going to be +2 in there, and the NO3 is -1. So the oxidation state for the calcium is 2 plus 2, and the oxidation state for the nitrite is -1. Not 2, it's -1 in there, because these two, they are multiplied with each other just to balance the charge of the calcium. For the hydrogen, the oxidation state of the hydrogen is +1. So why? Because hydrogen is a group number 1. Hydrogen is a non-metal. It is a non-metal, but hydrogen can lose an electron in there. So if I take an example as HBr there, hydrogen is a +1, and that balances the oxidation state of the bromine, which is -1. Here, hydrogen is going to be +1 again, so I have 2 plus that balances the 2 negative of the sulfate ion. Rule number 5, oxygen. So take a look at oxygen there. Of course, we have a lot of exceptions. So oxygen is one of them. So oxygen normally gains 2 electrons. So its oxidation state is -2, but not always though. Okay, so not always. So you need to pay attention. The oxidation number is -2. Not always. Whenever oxygen is balanced with a hydrogen, we call this a peroxide, H2O2. So if we have this case there, H2O2, then if you put the charges, you will see easily that the oxygen is not -2. Instead, it is going to be -1. So here the hydrogen is +1. It won't change. So I have a +2 for the hydrogen. Then the oxygen has to be +1, -1. I'm sorry, has to be -1 just to balance the hydrogen in there. So I would say, okay, I have 2 plus, 2 minus. They balance each other. So this is the case where oxygen has an oxidation number of -1 and not -2. In this example here, it's not coupled with a hydrogen, it's coupled with magnesium, so it's going to have a regular -2 oxidation number. Rule number 6 now, this is the most important rule when calculating the oxidation state of the whole molecule. So we say that to calculate the oxidation state for the whole molecule, the sum of the oxidation number of all the atoms in a complete compound is 0, unless the compound has an overall charge. Like, for example, magnesium sulfate. So here I have an example of magnesium sulfate, and I'm asked to calculate the oxidation number of sulfur. Sulfur is an atom in magnesium sulfate. It is one atom in magnesium sulfate. So this is how I do it. I don't know the oxidation state of sulfur. So that's an unknown for me. I'm just going to go ahead and build an equation. But I know that magnesium is a group number 2, right? So magnesium is going to be +2. And I know that oxygen is not coupled with hydrogen. So oxygen is going to be -2. So -2 times 4, that is -8. And I don't know what sulfur is. So I'm just going to go ahead and build an equation in there and say, okay, magnesium is +2. I have no idea what's sulfur, so I'm just going to put it as an unknown, X, for example. And then I do have 4 oxygens, and each oxygen is -2 oxidation number. The whole molecule, see, the whole molecule in there has a 0 charge. So I'm just going to make an equation and say, okay, this is 0 in there. Let's solve for X. So it's going to be +2 plus x minus 8 is equal to 0. X is equal to 8 minus 2, so that is going to be equal to +6. So now I know that the oxidation number for the sulfur is +6. Let's go ahead and double check that. So you need to double check your answer to make sure that your calculation is right. So this is going to be minus 6 in there. Here you go. So I know that this is going to be plus 6, not minus 6. So it's going to be plus 6, a plus 6. And I know that this is going to be minus 8, right? So 6 minus 8 is going to be what? That is going to be a total of negative 2. Negative 2 balances the positive 2. So now I have a zero charge, and my answer here is right. H2O2, and here I am calculating the oxidation number of oxygen. So this is an unknown, but I know that the hydrogen is a plus 1 and I have two of them. So I would say, okay, 2, the oxidation number of hydrogen is a plus 1, plus I don't know what's the oxidation number of oxygen, but I have two oxygen, so I'm just going to make it 2x. The whole thing is equal to 0. Let's solve for the 2x in there, or for the x. So 2x is equal to minus 2, and we said that x is equal, oxygen normally is negative 1 whenever it is coupled with hydrogen. And this is the proof over there. So this is negative 2 plus 2, the charges are balanced. Now, remember what we said over here, unless the compound has an overall charge, this is an example of that. So see this negative charge that you see for the compound? This is the overall charge. So now my overall charge is not 0, that is negative 1. So you have to take it into consideration. I need to calculate the oxidation number for carbon. This I don't know. So that is going to be my unknown. I'm going to start with the hydrogen. I know that the hydrogen is going to be plus 1. I don't know what carbon is because this is my unknown. And I know that I have 3 oxygens, and each of the oxygen is negative 2 because it's in a group number 6. The whole thing is equal to negative 1. So this that you see over here is the overall charge, you guys. So that is going to be 1 plus x minus 6 is equal to negative 1. Minus 5 plus x, that is equal to negative 1, implies x is equal to minus 1 plus 5, and that is equal to plus 4. So we're going to go ahead and come over here and say, okay, carbon is a plus 4, hydrogen is going to be plus 1 in there, and then the oxygens, I know that I have minus 2 in there. Minus 2 times the 3, this one is going to be minus 6. Minus 6, so the whole thing is equal to negative 1. That's true. So the whole thing is equal to negative 1. Then my answer is going to be right. Let's have more examples. HBrO3 negative, and I want to find the oxidation number of the bromine. So that is going to be plus 1 for the hydrogen. I don't know the oxidation number of the bromine, and I know that each of the oxygens is negative 2, and that is negative 1. Solve for x in there, so x minus 5 is equal to minus 1, and x is equal to minus 1 to plus 5, and that is again equal to plus 4. So this is how you calculate the oxidation number. Now let's define two terms in here, a reducing agent and an oxidizing agent. So a substance that contains an element that is oxidized during the reaction, we call this a reducing agent. It's the opposite actually. And the substance that contains an element that is reduced during the reaction, this is called an oxidizing agent. So let's go ahead and determine the oxidizing and the reducing agents in the reaction. So to determine the oxidizing and reducing agents in the reaction, you have to determine first which element is being oxidized and which element is being reduced, right? This is a chemical reaction, and this is how you do it. So we're going to start with the reactants first, and we're going to find the oxidation state for every element in the reactants. Starting with a 0, this is an uncombined element. Remember, this is rule number 1 in the oxidation number. So uncombined elements, they do have an oxidation number of 0 in there. I'm going to calculate the oxidation number of every single element. So I'm going to calculate the oxidation number of the hydrogen and therefore the oxygen. Oxidation number for the hydrogen is going to be plus 1. oxidation number of the oxygen is going to be -2. How did I know this? Because I know that oxygen is -2, right? Hydrogen has to be +1, so +2 minus 2, this is a 0. I can easily do that. And then hydrogen gas is an uncombined element, that is a 0. And then the sodium is going to be +1 in there. And then the OH in here. So if I take a look at the oxygen has an oxidation state of -2, and the hydrogen has an oxidation state of +1 in there. I know that the OH has a total of negative charge, right? This is a hydroxide ion, so it has a negative charge. So to have a negative charge, the oxygen here is going to be -2. Hydrogen is going to be +1. So -2 plus 1, this is -1. And this is why I have the -1 up there. So see what I did? I did the oxidation state for every single element in there, for the oxygen, for the hydrogen, and now I need to check out which element is losing electrons and which element is gaining electrons. So which element is being reduced, which element is being oxidized. So reduced means that it is gaining electrons. Oxidized means that it is losing electrons. Okay? Let's start with the sodium, because sodium is very obvious in there. So I'm starting with a zero charge sodium, and in the product, the sodium becomes a +1. So what did I do with the sodium? The sodium ended up losing electrons. Do you see it? It went from 0 to +1. So if it went from 0 to +1, then it is losing electrons. So sodium is losing 1 electron. So here it lost 1 electron. Implies, I would say, that sodium is oxidized. So this is called a half reaction in there. It's called a half reaction because like one atom is being oxidized. And the type of reaction that I'm going with here is called an oxidation reaction. This is called an oxidation reaction. In every reaction, you have half of it being oxidation reaction, and the other one is going to be a reduction reaction. So you got to figure out which element is being oxidized and which element is being reduced. So here the sodium is losing an electron, so it's being oxidized. So I would say this is my first oxidation reaction in there that is happening. Now, if you're having an oxidation reaction, then definitely, you guys, the element that you're starting with over here is going to be our reducing agent. This is the rule. So you look at your oxidation reaction, and then the element that is losing electrons, this one is going to be our reducing agent in this case. And now I need to look for the reduction reaction. Who is gaining? Who is gaining? I still have oxygens and hydrogens, and they're just choose any of them, you guys. So choose any of them. Here it's obvious. I'm not going to go with the oxygen because the oxygen did not change. See, it's -2, -2, did not change. But the hydrogen did. The hydrogen lost an electron, right? It was +1, and it gained and became 0. It was a +1, it gained an electron. So this one is going to be my reduction reaction. So this one is going to be my reduction reaction, where I can say that the hydrogen is gaining 1 electron. Okay, so if hydrogen is gaining 1 electron in this case, then I would say that water is going to be my oxidizing agent. Okay, so this whole thing, all the water now is going to be my oxidizing agent in this case. So sodium is going to be my reducing agent, and water here is going to be my oxidizing agent. So water is my oxidizing agent. Again, you look at your reaction and you see where is your reduction reaction. The reactants in the reduction is the oxidizing agent. You look at your oxidation half reaction and you look at the reactant in the oxidation reaction, and that reactant is going to be the reducing agent.